Okay, question number 1 says, which ordered pair lies in quadrant 4? So what we want to first think about is, where is quadrant 4? Remember, these are labeled 1, 2, 3, 4. So we see that quadrant 4 is this section of the graph down here. So I'm looking for one that has a positive x value and a negative y value, which would be C, 4, -2. That would be 4 spots to the right, 1, 2, 3, 4, down 2, falling right about there. Number 2 says, which ordered pair is a solution to the equation y equals 2x minus 1? So I'm plugging in these values to see which one gives it a true statement. Remember that these are both x and y values. So for example, if I were to plug in b, I would have 2 equals 2 times -2 minus 1. Well, 2 times -2 is -4, minus 1 is -5. I get 2 equals -5. So that's not true, so we need to try a different one. Best way to do this one is just guess and check. If I go to C, again, I'm going to plug in the x and the y values. I get -3 equals 2 times -1 minus 1. 2 times -1 is -2. Minus 1 is -3, so I get -3 equals -3. So that's true, so the answer is C. Number 3, the graph of the equation x equals 2. Okay, if we think about this, x equals, that's one of those special cases. The x-axis, we're finding where it's equal to 2 on the x-axis, which would be falling right there, and then I'm going to get all of the points that have an x value of 2, and that creates a vertical line that looks like this. So number 3 is B, a vertical line. Number 4, which of the following is always true of an x-intercept? The x-intercept is the place where the graph crosses the x-axis. If here is a random line, the x-intercept is where it crosses the x-axis, so that would be true. B says the x-intercept has an x-coordinate of 0. It could if it went through the origin, but it doesn't always go through the origin, so 4 is A. Number 5, what is the x-intercept of the graph of the following equation? Okay, one thing we know about the x-intercept is we know that the y value is 0, so we can immediately get rid of A because that has an x value of 0. I find the x-intercept by plugging in 0 for y. So plugging in 0 for y is going to make it 0. Anything times 0 is 0. That leaves -4x equals 20. I can then divide by -4. 20 divided by -4, I get x equals -5. So I see that that would be C. Same exact process for the next one. I'm looking for the y-intercept now. I'm going to plug 0 in for x. 7 times 0 is 0. That leaves me with -y equals 10. I can then divide by -1 on both sides. 10 divided by -1 is -10. So my intercept is going to be 0, which is what I plugged in for x, -10, which is C. For numbers 7 and 8, we're filling in the table, and they give us the values. So all I'm going to do is evaluate, okay? 2 times -1 minus 5. 2 times -1 is -2, minus 5 is -7. 2 times 0 is 0, minus 5 is -5. 2 times 1 is 2, minus 5 is -3. 2 times 2 is 4, minus 5 is -1. For the next one, we have the absolute value. Remember, absolute value makes things positive. So the absolute value of -2 is going to become +2. And then I'm going to add the 7 onto that. So 2 plus 7 will give me 9. 0 plus 7 gives me 7. 2 plus 7 gives me 9. Sorry about that. And 4 plus 7 is 11. For these next ones, we're determining if something is a function or not. When they give us a table, we're looking for repeated inputs. If I look, 0, 2, 4, and 6, none of them repeat. So this is a function. When they give us a table for identifying the domain, it's our input or our x values. So I'm just going to list them. 0, 2, 4, 6. When I'm identifying the range, I'm just going to list my output values or my y values. So I'm going to take these values right there. Negative 1, 0, 1, 2. This next one, they give us a graph. So with the graphs, we're going to use the vertical line test. If I can draw vertical lines and I never hit the graph more than once, it's a function. So this one here passes the vertical line test. Yes, it's a function. For my domain, I no longer have just single points, but any point that falls on the graph. The arrows on the end tell me that this is going to continue. So it's going to continue going to the right. It's going to continue going to the left. So my domain is going to end up being all real numbers. My range is a little different. My range will never go below 0. It will continue to go up, giving me all of the positive y values, but I'll never have anything below 0, so I'll always have only positive values. I can write this as saying y is greater than or equal to 0. For number 11, we're looking for the x and y intercept. Remember, x-intercepts have a y value of 0. Y-intercepts have an x value of 0. So I'm going to actually fill that in for both of these problems right now. When I'm looking for my x-intercept, I plug 0 in for y. So 4x minus 0, which is going to be 4x, equals 12. I can then divide by 4. And I get x equals 3. I can repeat the process for my y now. 4 times 0 is going to be 0. That's going to leave me negative y equals 12. I'm going to divide by negative 1. And I get y equals negative 12. Okay. On the other side, 0 goes in for y, leaves 5x equals negative 40. Negative 40 divided by 5 is going to be negative 8. When I do it for the y value, 0 is going to go in for x, leaving me 8y equals negative 40. Sorry, I'm running out of space. Negative 40. I'm going to divide that by 8, so I get negative 5. Okay. For number 13, it says we can use any method and we need to plot at least 2 points. I'm just going to make a quick table. X, Y. If I plug in 0, 3 times 0 is 0, minus 4 is negative 4. And I can plot that point on my graph. 3 times 1 is 3, minus 4 is negative 1. And I can plot that point on my graph. And then I can draw the line to connect those. Remember, we should be filling the coordinate plane all of the way. Okay. This next one I'm going to run out of room, so I'm actually going to do a table again. And I'm going to do some negative values so that I can fill this in. So for my x, I'm going to plug in the following. Give me 1 second here. Negative 3. I'm going to plug in negative 1. Okay, I'm going to plug in 0. When I plug in negative 1, I get 12. When I plug in 0, I'm going to get 9. So my graph isn't going to fit perfectly. Okay, negative 112, these go up to 8. So I'm actually going to count by 2's here. Let me zoom in over here. So negative 1, this is going to be 2, 4, 6, 8, 10, 12. So I'm going to go negative 1, 12. 0, 9 is going to be right there. And I can draw the line. Sorry about it not fitting too nicely on there. Okay, on to the next page. So for these ones here, we're given functions, and we're going to fill in function notation. So number 15, we want f of negative 1. So that means I'm going to use the f of x function. So f of negative 1 is going to be 3 times negative 1 minus 4. 3 times negative 1 is negative 3. Minus 4 is going to be negative 7. So f of negative 1 equals negative 7. For 16, I'm going to use the g of x function. So I want g of negative 8. So that's going to be the absolute value of negative 8 plus 3. Negative 8 plus 3 is going to be negative 5. So I'm taking the absolute value of negative 5. The absolute value of negative 5 will be positive 5. For the last part, we have a word problem. Tall Paul was 22 inches tall when he was born. Since then, he's been growing 4 inches per year. He is currently 14 years old. So we see that when Paul was born, he was 22 inches tall. After 2 years, at growing 4 inches per year, Paul would now be 30 inches. Year 1, he would be at 26. Year 2, he's at 30. In year 4, he would be 38 inches. And in year 6, he would be 46 inches. How tall was Paul on his 5th birthday? Well, that would be falling in between those two. So he would be 42 inches tall. How old was Paul when he was 62 inches? Now, I could continue my table. I could also look at my graph. Now, I can see this graph is going to be a little difficult because of the way it's counting. I have 0, 22. So that's going to be right here. I have 2, 30. I have 4, 38. I have 6, 46. Sorry, it's not plotting. So if I were to connect that line, 62 inches would be falling somewhere in there. So it looks like he should probably be 10 years old. Okay, let's check that. I'm actually going to fill in my equation now. My equation to model this, Paul is growing 4 inches per year. So 4 times x plus the 22 inches he was when he was born. So I can set 62 equal to 4x plus 22, and I can start solving that. If I subtract 22, I'm going to get 40 equals 4x, and I get x equals 10, so like my graph said, he was 10 years old when he was 62 inches tall. That is the end of the review that I will be doing here. You do have the extra pages if you want extra practice.